Hey everybody, I hope everyone's doing well today. In this video here, I wanted to go over another smart contract hack with you guys here in the Ethernaut level. In this video here, I want to go over token. This is a level 2 challenge from here. The goal of this level is to get more tokens than you currently have when you deploy the contract. By default, you're given 20. If we type in let result equals result dot to string, you can see in my wallet from here I currently have 20, so I deployed an instance before the video started just to save on a little bit of time here. And the goal is to get more than 20 tokens, preferably a higher number of tokens than you currently have from here. So if we take a look at this contract from here, we have a pretty simple contract. If you haven't done any type of Uniswap work or ERC20 work, this should look pretty familiar, albeit this is a very stripped down version from here. So we have a mapping for the amount per address here, how many tokens each address has here. We have a total supply here. When the constructor is called, obviously there's a total supply and the initial supply. Right, we have a transfer function, and then we have a balance of function to look up the balances of particular wallets from here, of the owners here. And that's what I called right there. So if we look at this contract by default, it seems pretty secure here, right? We're making sure that they can't spend more than they currently have in the wallet. We're subtracting a certain value from the message sender, and then we're adding it to the to wallet, and it's returning true. So at first glance, it might be like, hey, can I maybe do something with this return true? But that probably wouldn't work here because it's not really conditional. If we do a require statement, either it's going to run or not run from here. One of the things that we have to take note of is stuff, not necessarily within functions here, but stuff with the compiler version too. So let's go over to remix from here, what I did before the video started, and we can actually clear this out here. Yeah, it's all right. Just leave it up for now here. I set up this little contract here, and this is just a test contract, and this uses Pragma Solidity greater than 7 and less than 9 here, so a pretty current version of Pragma. And we have a number. We're able to subtract from the number, and we're able to add to that number too. And I'm actually going to put add above subtract here, just because that makes more sense in my brain here. So why would I set this up? Well, first off, let's see how it will work. And let's format this a little bit here. And I'm on the VM just for right now, just to make life easier. Let's go and deploy it. And this would work just like we think it would. We currently have the number, which is set equal to 1 here. If we add 1 2 times, we should see 3. If we subtract 1 2, we should see 1. If we go to 0, if we try to go less than 0, it will revert from here. So that's working like it should. Now, if we go back to Ethernaut, but keep in mind here, on this particular contract, this is using a different compiler version than we're using right here. You know, I think there's sometimes, as coders, we kind of glance over that fact sometimes. We think that this is the code. And it's like, yeah, this is the code, but this isn't the machine code. This is a human readable code. So just because this code is the same as if I change like the compiler version, just because the code that we write looks the same doesn't mean the machine's going to kind of run it the same way here. Because remember, the machine doesn't read this code. The machine reads the code that's run through a compiler, right? So if I change the compiler version, let's take this, the one that they use here, and let's put this right here, and let's see if this is any different now. And I'm going to save this, and I'm going to double check here, because if you notice a jump cut in the video, it didn't quite save at first. But anyways, from there, we're going to get rid of that old contract. Let's deploy the same contract, but with a different compiler version, and let's see what happens now. Let's deploy this here. If we have the number 1, we add number. 2, working like it should. Subtract 1, subtract 2. We're down to 0. Now, if we subtract again, what's going to happen? Well, that's kind of weird that it went through. We should have seen it revert. Well, basically what happened is it overflowed, or underflowed in this case here. So it kind of wrapped back around to the highest number that could be stored in this uint number from here. If you're not familiar with binary and what like an uint8 or like a uint256 is, with the difference between the two here, I can definitely make another video on binary and how those kind of work there. But just keep in mind that this version of Pragma Solidity, basically one of the issues with it was that it can overflow and underflow from here. And the same thing, like if I take this number, just for demonstration purposes, and I paste that right there, let's save, let's remove this from here, let's deploy it. And maybe this will make more sense for some of you guys. I have this number here. If I add a number, would now be overflowed back to 0. It's like a big circle kind of wrapped back around to itself from there. All right. So what does that mean here? That means that well, first off, that means that always look for the compiler version, the one that you're using, and be aware of that for 6.0 or greater. Usually what you see with these types of contracts, you see is something like import safe math, import, something like safe math. depending on when they have it, safe math.sol. And this allows for the proper usage of these numbers, and this way they don't run over, they don't overflow, I should say here. But anyways, if we go back to this contract from here, basically what we can do now is we can wrap this number back around to give us more tokens than we really should have. Remember that a lot of times in smart contracts, and honestly just computing and banking in general, right? We're not really moving physical tokens around, we're just changing numbers on a screen here. So just because this, like even though the total supply would be a certain number here, this total supply, it's not like it's going through and counting up all of the tokens that are in there. This total supply is just a reflection of what was deployed sort of at runtime, if that makes sense. So now what I'm going to do from here is I'm going to go to my Ethernaut, and I'm going to copy this contract from here because I want to interact with it through Remix. And let's go and paste this from here. And let's load this address up, but first I have to switch this over to MetaMask, injection provider MetaMask. Let's load up this contract. Now we could make another contract to interact with this one. I really don't think it's necessary. I think the simplest way to do this from here is to switch to a different account and then try to send coins from that account. Because remember, this expression right here with this compiler version is going to result in a rollover, which would really make this to be true from there. I should say this expression would result in a rollover, which would make this expression to be great, to actually return true. And then this way the require statement wouldn't run. It would keep going with the rest of the function. So what I'm going to do is I'm going to go to my MetaMask and I'm going to switch to a different account. I'm sure there's more than one way to do this from here, but I'm going to switch to a different account. And I'm going to try to send, actually I need, if we go, I forgot, I need that first account address. And let's try to go here, copy that from there, go back to there. We're going to say, first off, balance of, still have 20 from there. Let's drop that down. Let's send that to, and let's send, I don't know, let's send 21,000 tokens. Let's transact. And confirm. And we're waiting. Cool. And that transaction went through. Now if we go back to balance here, we can see that all those tokens got sent. Because remember, this is doing that rollover function from there, which is allowing the rest of this function to run from there. All right, let's go back to our contract. Actually, before we do that, let's switch this back to our main wallet, the one that was deployed with the instance address here. And let's go back to Ethernaut. And we might have to refresh. I think we're actually good. One more time, let's go and see the balance of this account here. Result.toString. We can see that we have all those tokens. Let's submit this instance and confirm, and let's see if we did it right. Cool, it looks like we beat the level. So if you guys learned something, if you guys enjoyed, be sure to give me a thumbs up, comment down below, and subscribe. And if you guys are able to, definitely support your local animal shelter, drop off some blankets that maybe not using anymore, some dog food, some kibble, even just a straight up cash donation is fantastic for those guys. And I hope you guys have a fantastic day, and I will see you guys in the next video.